Right. Bismillahirrahmanirrahim. Welcome to the third lecture on Z transform. So far we have discussed foundations of the Z transform. Right? क्या क्या किया हमने? We have established the background of the Z transform. Right? कि ये idea आता कहाँ से? Where is the idea really coming from in the terms of eigen functions? Right? And after that we have gone into some details of the Z transform, how it is related to signals going through systems, right? So उसमें हमने क्या कोई किसी को याद है कोई एक दो की रिजल्ट्स क्या बता सकते हैं आप? Radius convergence that was related to the way Z transform is defined, right? What else? कोई और बात आपको याद आती है? You can recall transfer function, right? That was what? What was it exactly? Z transform of the impulse response, right? So that's good. आपको इसका अंदर याद है हमने region of convergence of the Z transform definition we covered that. And you mentioned about transfer function, which was in fact the Z transform of the impulse response, right? Or kya, any other concepts, key concepts or results that we have looked at? Inverse Z transform, right? Going back from frequency domain to time domain, right? So we have discussed the inverse Z transform. We often write it like this: Z, the inverse transform. Okay. What else? In terms of systems, as you mentioned already, impulse response is Z transform is the transfer function. Okay. But what happened to finding the output of an LTI system? उसमें क्या change आया था? How were we finding it before Z transform? Through convolution. Now, with the help of Z transform, where are we? We do it with simple multiplication. So the process is that previously you had xn, right? And it went through a system that had an impulse response hn, and it came out yn, which was convolution. Now we take a roundabout way, right? What's the roundabout way? You go to the Z transform of this and the Z transform of the impulse response. So this we call xz, right? The input in Z domain, right? And this we call the transfer function, which we then write as capital. Usually the convention is to represent the frequency domain or the transform domain, we normally shift to capital letters, okay? And then this inside will tell you if it is Fourier, Laplace or Z. For Z transform, it's common to have a Z here. For Laplace, it's common to have an S here. And for Fourier, it's common to have either an F or omega, depending if you want hertz or radians. Okay, so we will come to the other two later. But how are these concepts then connected now? Firstly, of course, to be able to take the Z transform, you have to be able to define it, right? And in its definition, inherently there was something we saw, region of convergence. Then to pass this through an LTI system, you have to take the Z transform of the impulse response, which is the transfer function as you mentioned now. And where does the inverse Z transform come in this whole thing? Do you know? Can anybody tell me? First, I'll tell you here. We had xn convolved with hn, but now what we get is basically yz, right, is 8z times xz. And we proved this last time. आखिरी चीज यही की थी ना, we proved it, yeah, that this holds. We also proved that Zn happens to be eigenfunction of LTI system upon which the whole idea of Z transform is based. Now you get the output, okay, in time you get like this. So where does Z transform, inverse Z come in all of this? Someone among you mentioned the inverse Z transform, right? So you see where does this come in here?
To convert back to time domain.
Convert back. Often, yeah, this is good analysis, okay? But humans, or the way we study data or look at it, is often in time, right? It measured in time, or we want to have it in time. So it's good for analysis, and often we stick to this, but it is much more common after all the operations are done, you want to go back to the time domain. So that is where the inverse Z transform often comes in. ऐसा नहीं है कि हम we take the z of x and then we take the inverse of z of xz to get xn just playing around, right? There is usually a need. So usually that need occurs after some operation has happened, okay? Using this we avoided this complex thing, and of course there are other, I will show you later, other benefits in doing that, but then you are back to the time domain. So all that you have learned so far is combined here, इसमें आ गया बस ये, ठीक है? तो I mentioned last time, in our third lecture now, we will go and make our definitions more formal. That's one. Second, we will practice solving some real examples. And then if there is time today, or maybe it's in the next lecture, we will discuss how do we actually perform the Z transform. पहले तो हम definitions करेंगे, some simple examples to see, to drive home the idea of Z transform, region of convergence, properties of the Z transform, okay, pairs of Z transform, those things. So let's see. This is done, this is done, yeah. So we will try to get to know the Z transform better. Firstly, let me define it formally. This is xz, n is minus infinity to infinity, xn z minus n. Okay. So Z transform, defining Z, this is the first definition. It has two definitions commonly in use, okay? This is the first one, and we call it the bilateral Z transform, okay? There is a second definition which we call the unilateral Z transform, which basically works for positive n value. That is only where the difference lies, okay? And here you have xn z minus n. This is unilateral Z transform, and we won't dwell too much on this in this course. The difference between them, basically this one is more suitable for causal signals, okay? There are some other differences in the region of convergence, but since this is your first introduction to Z transform, I don't want you to get bogged down in this detail. The only reason I'm mentioning both of them here is that generally if you go somewhere or look at some context, some reference material, there might be written, okay, this is the bilateral, this is the unilateral. So you may think, oh, okay, what's that? Yeah. So basically, This is, it's only the difference is here, and just keep in mind that the second one is more suited to causal signals. Remember causal? कुछ याद है? Right? So वही है जो आपको hopefully whatever you remember is the right one. But otherwise their behavior is very similar, and for our purposes as a first introduction to Z transform, we will mostly stick to, I think your book has both of them, but most probably we'll stick to bilateral Z transform. Okay, this one, which is a more general case. Now, with the definition set aside now, this is the definition, okay, nice. Take one of them, let's say we stick to this one. Then the natural question next is, what is Z, right? And I've already mentioned that in the previous lecture. So what is Z here? Zn is the eigenfunction of LTI, right? But what exactly is Z? Variable है, कोई number है, कोई constant है, क्या है Z? याद है कुछ? Any complex number, right? So complex sinusoid is a special case inside that. So now from here on, keep that in mind. Often students they work with Z transform a lot, but if you ask them this simple question, okay, what is Z? Like okay, it's not a magical number or anything. It's a any complex number which you could have written as E plus J B. Remember when we revised complex numbers at the start of this course? And इसकी polar notation क्या थी? Let's say amplitude A, E, J, theta, right? And now this makes Zn, when n is, let's say, minus infinity to infinity or 0 to infinity, this makes Zn a complex exponential, right, in general. And special case kya hai? Special case of this here, let's say, is that Z is Ej omega. Okay, so amplitude is gone and you only have Ej omega. इसको आप अगर write out करें तो क्या बनेगा Euler identity से? Cos omega plus J sin omega. ऐसे ही है ना? Remember we have discussed the complex sinusoid before. So that is the general, special case. And then what is Zn in that case? If Z is this complex thing, then it is Ej omega n, right? यहाँ पे this is just one value. You put omega and you get one value of cosine and sine, right, in the complex one. To make it that wave, जो real part or complex part is cosine and sine, which I have shown you the animations of, you need the time index also, right? So now Zn is that proper complex sinusoid. अब ये कैसे हो जाएगा? It becomes cosine omega n plus j sine omega n. What does this look like? As n varies, time के साथ साथ, what's happening? The real axis is making the real part is making the cosine wave, and the imaginary part is making the sine wave. Wave बनेगी जब time भी अंदर आ जाएगा, n. Okay, before time it's just one value, wave पे कोई एक point बनता है बस. Okay, so then the complex exponential changes into complex sinusoid properly. Okay, so coming back to the original question, okay, this is the definition, but then what is Z? Firstly, Z is a general complex number, that's one. Second, a special case of that complex number is this complex sinusoid, right, that we use. we will see if we need to go further in there. But then with the definition of the Z transform, if you remember, we also had additional requirement. What was that? For this to exist, this sum, it's a sum of an infinite series, isn't it? This sum has to converge. If this sum doesn't converge, your definition explodes. You cannot get the Z transform, right? So for this sum to converge, you have to, of course, you cannot force people to change their input. Accent तो उनका है ना, आपने उसका Z लेना है, right? So what you can do is force your Z to not take any value on the complex plane, but to take a fixed set of values, and that fixed set we call region of convergence. Region of convergence of what? This infinite series, which is the definition of Z. अगर ये converge नहीं करेगी, doesn't converge, the definition explodes, doesn't work. Yeah. So what does that tell us? Okay, firstly, this is the definition of the Z transform. What is Z? We have looked at it here. Yes. And now we have an additional thing here, that along with the definition there goes the idea of region of convergence, ROC. So that you have today we will look at that also in some detail. So usually whenever we define, you give me a sequence xn, yeah, I give you its Z transform, and along with that I also give you region of convergence. That yes, you can take the Z of this signal like that, but it will only work if you choose Z within certain range. So let's do a couple of solid examples to bring this thought home. Let's see. Any questions so far? Foundations we have already discussed, right? Background idea पूरा वो हमने develop कर लिया और बड़ी detail में पूरे 2 lecture लगा के. अब now it's time to get into the nitty-gritties, right? And to get into more, let's say, solid examples, actual signals को अब हम देखते हैं कुछ. So let's say you have a signal xn in time domain 1, 2, 3. कुछ याद है ये एरो क्या करता है?
Zero origin.
Zero origin था, meaning this is n equals 0, meaning x0 is 1, x1 is 2, x2 is 3. अगर बीच में कहीं 0 लाना हो तो मतलब x1 को अगर 0 रखना होता है तो हम यहाँ पे 0 डालना पड़ता है, right? So you set the origin. उसकी left भी हो सकता है, okay? But normally for my own convenience I have these kind of examples. I could make it bigger to the left also. वो फिर क्या हो जाएगा? x -1, x -2 and so on. Yeah. Plot कर सकते हैं इसको. Simple, right? How does it look? 1 at origin, sorry, 1 here, 2 here and 3 here. ऐसे simple एक signal. Find its Z transform. I'll let you try. Definition मैं दोबारा लिख देता हूँ. It won't matter which one we use here, but let's say I give you definition of the unilateral one. हाँ जी, try करें. You have the definition, you have xn, find the Z transform. A hint is कि ये कोई number नहीं आएगा, terms आएंगी कुछ, ठीक है? So what are those terms? नजर आ रहा है? वहाँ देखना है. बिल्कुल नजर नहीं आ रहा. बोर्ड पे आ रहा है, वरना आप लोग जी जो कर लें पहले वो बता दें मुझे। You only have to expand the series, कोई लंबी चौड़ी कैलकुलेशन नहीं लग जाना. It's not the midterm exam. सही जा रहे हैं. x0 is 1, z0 is 1, yeah, plus x1 क्या है 2, 2z inverse
ये सही है
2 by z or 3 by z
plus 3z second power, yeah, ऐसे ही है ना.
जी
Yes, exactly, good. Yeah, okay. नहीं एक second. z0 z1 z2 होगा ना. इसमें
ये सही है 0
हाँ ये
z1
z3 पे कैसे गया इनकी वजह से. भाई ये वेट नहीं है, कॉपी ना करेगी. Right, got it. That's the series you get, right? So does Z transform doesn't always lead to a very elegant closed form solution, okay? So in this case it is 1 plus, because if you expand this you have x0 z0, x0 is 1, then you have x1 z minus 1, x1 is 2, so you get 2 z minus 1 plus 3 z minus 2. That is the Z transform of this sequence. Is this definition enough? What's left?
convergence.
Region of convergence. Okay, so this, you haven't completed your task yet. You give me the Z transform, but then you also have to tell me what values of Z am I allowed to use. Quick thinking, क्या होगी? कौन सी values allowed? Remember, Z is what? A complex number. ये complex plane है. This is the imaginary part, this is real part. A complex number can exist anywhere. जैसे real number इस line पे होता है ना. Complex number can be anywhere on this plane. That's Z. But now, what does this restrict Z to? क्या?
सर 0 0 नहीं है
Zero allowed नहीं है. क्यों? Zero का inverse
Infinitive
infinite हो जाएगा. बाकी सारी finite values allowed है. तो यहाँ पे you can put a cross here and then say everything else finite जहाँ जहाँ भी है is allowed. So what is that? Basically you say all complex plane, right, except z equals 0. Good, right? So you have the entire complex or the set of complex numbers except for z equal to 0. So now you have defined the region of convergence. Okay, try an interesting one. This was just some made up example. What if xn, the input is delta? Remember delta? Xn equals delta n. Now find the Z transform. जल्दी से, बहुत फास्टली आप कर सकते हैं.
ये होगा उससे
One. Is that definition complete or something left?
to 0.
So xz is 1,
Yes.
right? That's fine. फिर क्या रह गया साथ?
Convergence.
Region of convergence. What's that?
Zero. So all values except one.
Zero.
सोचे सोचे.
So we
Fair.
defined at 0, so
तो वही मैंने बोला.
But-
Sorry sir, zero. Except zero.
Except 0.
हाँ.
क्यों?
Sir zero के ऊपर ही सिर्फ होती है आपकी डेल्टा वो one.
No,
बाकी
no, no.
values के
Think
ऊपर
about
zero.
it. You have to think about it in terms of the series. Yeah. What was the series you got? Xz was summation xn z minus n, right? So that series is xn z minus n. Now in your case, xn is delta n, which means it exists only at delta 0. So you had to put here x0, which is 1, and z minus 0, which is 1. So this thing came out to be 1. Now look at this term. Finally you got 1. Is that right? Now what values of z are you allowed? 0. What does 0 mean? Like
Only zero is allowed.
only 0 is allowed.
yeah,
Okay.
only
So
values.
for what value of z would this series converge?
Any
Any value. Z है ही नहीं उधर. क्या हो गया? Z isn't even there. Is it there? देखिए जो previous example थी, right? That was the previous example. There was a z in there. So putting z equal to 0 made this thing infinite. Everything else was fine, right? इसमें तो z है ही नहीं है. ठीक है? Since there is no z, this guy doesn't care. This sum exists whatever value of z you choose. Why नहीं? So इसका region of convergence क्या है? Entire complex plane, right? So and this is one of the fundamental actually. अच्छा, we will also look at what we call convolution. Transform pairs. Okay. So time में कोई सिग्नल कैसा लगता है तो उसका फ्रीक्वेंसी या ट्रांसफॉर्म में वो कैसा लगता है. तो इट्स ऑलरेडी स्टार्टिंग हियर. वी वर्क विद कॉमन पेयर्स. ये बहुत ही इंपॉर्टेंट पेयर है. इट्स सेइंग दैट इफ योर सिग्नल looks like delta is an impulse in time, it becomes what? So if it is like an impulse in time, discrete time पे हम काम करें, right? If it is this thing, in frequency or z transform, it becomes a constant line. यही है ना x z equal to 1. इसका मतलब z की कोई हमने limitation तो नहीं दी कहीं भी, ना ROC में ना वैसे. That means all values of z are 1. At all values z it's 1. So impulse response in time becomes what? This thing in frequency, it becomes a constant, fixed one value, right? अब इसमें एक बड़ा इंटरेस्टिंग आपके लिए रिजल्ट है. कैन एनीबॉडी रिकॉल, चेक करते हैं आप लोग कितनी रिवीजन करते हैं. व्हाट वाज द आइडेंटिटी ऑफ कन्वोल्यूशन? राइट, right. Identity, do you remember what's an identity? What's the identity of summation?
0.
0, right? So if you add, like there is a number a, you add 0 to it, you get a. So we say 0 is the identity of addition. What's the identity of multiplication? 1. What's the identity of convolution? We did that.
Delta n.
Delta n. Remember? So the identity of convolution, convolution, if xn convolve with delta n, we proved it, is again xn. Yes? Now notice this thing happening now. Take a careful look. If I were doing this multiplication in the frequency domain, so if I were working with xz and the z transform of this thing also, yeah, what would I get there? This xz and the Z transform of delta n should again be xz, isn't it? If I take the whole Z transform, but notice what's the Z transform of delta n? 1. So 1 times this is xz. See? Makes sense. Okay? क्या हुआ है? In frequency domain, convolution turns into product, right? So in time domain, delta n was the identity, but product में तो हमें पहले ही पता है क्या होती है identity 1. So automatically delta turns into a 1, right? ये अभी हमने mathematically निकाला, but it has sense to it. इसके और भी meanings हैं, वो हम आहिस्ता आहिस्ता आएंगे, but it's a very powerful and useful result. An impulse in time becomes a constant in frequency. Okay, constant value बन जाता है. Right. What about अच्छा इसको often we write pairs like this also. यार ये तो मैंने draw कर दिया ना, but we also like to write pairs like this, that delta n corresponds to 1. Okay. ये arrow two sided है, yeah. There is actually a reason for that. The inverse Z transform भी show कर, but there is also another reason, duality. I will discuss that later. So I will now let you try out for about 3 or 4 minutes what will be the Z transform of UN. याद है आपको UN? क्या होता है UN?
Unit step.
Unit step, right? So in discrete time, what does the unit step look like? It starts at 0 and stays at 1, right? 1 1 1 1. ऐसे ही है ना? That is UN. What is the Z transform of UN? Find that.
UN
है?
one.
नहीं नहीं 1 नहीं. Guessing game नहीं हो रही है.
सर आपने जो ग्राफ बनाया है 1 1 1
हाँ, UN है ना? UN की definition ये है कि it is 1 from 0 onwards, right? Before that it is 0. यही था ना definition. UN equals 1 for n greater or equal to 0 and 0 otherwise.
Infinity.
हाँ? ये अच्छी जान छुड़ा रहे हैं. क्यों भाई? कैसे?
Plus 1 plus 1 plus 1.
So 1 plus Z inverse plus Z minus 2 plus Z minus 3 and consecutive आगे चलता है.
हाँ, तो ये infinite series होगी.
जी सर.
तो क्या फिर इसका क्या बना?
सर 1 by इसकी वो कोई कन्वर्जेंस वाली सर होगी, वो अब याद नहीं है कैसे करनी.
What series does it remind you of?
Geometric.
Geometric. Geometric series, does it always converge? Does it always diverge, or there are some conditions?
सर converge करती है.
1 पे कन्वर्ट
Condition है ना? उसके जो exponent से जो नीचे base होती है, उस पे होती है condition. So good, you are getting there. I will write it out for the rest of you. So then we develop the solution together. But I think आपने वो main idea you have got it. Let's see. Firstly, xz, ये मैं इसलिए दोबारा से लिख रहा हूँ ताकि आप लोगों को थोड़ा practice हो जाए. Z minus n. Now xn is un, right? So it's 1 1 1 1. That means we are dealing with 1 z 0 पहली term plus 1, वो लिखने का फायदा नहीं. Z minus 1 plus 1 z minus 2 plus z 3 and so on. Yes. Now I could also write it for your convenience as 1 plus 1 over z plus 1 over z square. है ना, ये ऐसे ही है.
जी सर.
जी
बेसिक मैथ तो याद है ना. Now what does this remind us of?
Geometric series.
Geometric series. Yeah. So let's say I want to write it as a general geometric series A R एन, याद है?
Yes.
इसमें ए क्या है?
One.
वन है। आर क्या है? जो रेशो थी वो क्या है? वन ओवर z। इस फॉर्म में तो वन ओवर जी आएगी, वन ओवर z. Now this form of geometric series, when does it converge? This geometric series, so this is, कब converge करती है? जीरो। किसकी वैल्यू जीरो? कुछ तो याद होगा, किस पे डिपेंड करता है? कौन?
R.
R, हाँ, एब्सोल्यूट वैल्यू ऑफ R ग्रेटर देन वन हो तो ये डाइवर्ज करती है, राइट? वो तो आप टेस्ट भी कर सकते हैं, यहाँ टू रखें या -2 रखें, दोनों सूरतों में 2 स्क्वायर 2 क्यूब वो बढ़ता जाएगा, ऐसे ही है ना? पॉइंट में रखें 0.3 तो नीचे जाएगा, तो दैट मेक सेंस. सो इट कन्वर्जेस इफ R इज लेस देन 1, राइट? 1 पे भी कन्वर्ज नहीं करती, वो चलता जाएगा. So what do we get? What does this say to us? It says that 1 over z has to be, absolute of 1 over z has to be less than 1, right? That's one thing. How can we write it another way? Is to say that absolute of z is greater than 1. Inverse है ना, right? तो अगर आप उल्टा करेंगे तो ये sign will change itself. Yes. Now ये तो हो गया, this is the condition for it to converge, which basically is giving you what? Region of convergence. But what is the form? Is the, once we know that it converges, if R absolute is less than 1, we know it does converge. उसका फिर एक formula है, you've been taught, the sum of a converging geometric series. A और R की terms में निकलता है, I'll write it here. We know that summation ARn equals A over 1 minus R, right? If and only if what? R is less than 1. ये है वो, ये कितना simple सा एक formula निकल आता है, yeah? You got a very simple. We've done this in calculus 1, 2 somewhere. A 1 minus R, R absolute is less than 1. Now we have already said, okay, we will stay in this region. Now give us the sum, right? We're gonna stay in a region where it is convergent. Now what's the sum? तो इससे निकाल सकते हैं आप, क्या बनेगा इसका?
Sir, 1 by 1 minus z.
A is 1, yes. 1 by
1 minus 1 by z.
1 by z. अगर ये हम z से मल्टीप्लाई एंड डिवाइड करके थोड़ा इसको एलिगेंट बना लें, तो ये बन जाएगा z over z minus 1 with R और C हम पहले ही निकाल चुके हैं. We couldn't have come to this without the R or C this time, right? क्योंकि अगर आप, if you don't commit to staying in this region, the sum doesn't even exist. Yes, so you couldn't use that.
Geometric series वगैरह भी याद करनी पड़नी.
क्या याद करना है?
मैं वैसे generally मैं पूछ रहा हूँ geometric arithmetic series वगैरह भी याद करनी पड़नी.
No, that's maybe this one. Right? Very few basic things. Yeah. I don't know. I recall maybe I give this formula even in the exams. But इतना तो आना चाहिए मेरे लिए तो. ये चीज़ तो कोई और सीरीज नहीं यूज होनी. You can imagine ये फॉर्म है ही ज्योमेट्रिक की असल में ना, जनरलाइज्ड फॉर्म है, इट्स अ जनरलाइज्ड फॉर्म. या सो अदर सीरीज अरिथमेटिक वो भूल जाए, इस कोर्स में नहीं, दे वोंट शो अप मोस्टली. राइट. सो व्हाट्स द z transform of the unit step now? It's z over z minus 1. That's one thing. The region of convergence is z greater than 1. Any of you can plot this. बोनस नंबर मिल सकते हैं, लेकिन पता नहीं वो हम डालेंगे आगे तो. रीजन ऑफ कन्वर्जेंस क्या है? एब्सोल्यूट ऑफ z greater than 1. Can any of you plot it? क्या बनेगा?
Straight line.
कहाँ पे?
Numerical react
Positive place.
positive
Okay, firstly of course z has to exist in the complex plane. Yes. Now what is absolute of z greater than? I have done this in another context before. Okay, so now when we looked at complex exponential long ago, I have drawn something like this.
So once
Just ask yourselves questions one by one. Okay, firstly, z is a complex number. Yes, so it has to be in the complex plane. Okay, what's the modulus of a complex number? It's what? किस चीज को represent करता है?
magnitude
Magnitude.
Yes.
Magnitude को करता है, वो दोनों एक ही मतलब है ना? What does magnitude mean then? In context of this, किधर है वो? What does magnitude tell us?
real square plus imaginary square under root.
वो भी हो गया, right? वो क्या होगा यहाँ पे? Distance from the origin. How far is this? जो भी z है, उसका जो distance from the origin, the absolute जो होता है, इसको हम z absolute कहते हैं ना? भूल गए? यही था ना? फेस का ये जो एंगल बनाता है वो इन दो की मदद से you can find where it is, right? Polar notation, that is what it is. So now अब मैंने help कर दी आपकी. This is saying the modulus of z must be greater than 1 for this series to converge. अब क्या एरिया बनता है? अब प्लॉट कर दें. What's the region of convergence?
Sir, once the giant straight line
Hmm.
और once the straight line ऐसे horizontal.
उससे ऊपर चले जाएंगे
ऊपर चले जाएं. ओके,
Straight.
इस पॉइंट का रेडियस क्या है? डिस्टेंस कितना है? लेट्स से इस पॉइंट का अगर 1 है, इसका भी अगर 1 है, both of these have radius 1. There is another point that can have radius 1. So we are talking about a
Circle.
circle, right, of radius what? 1. ये वो z की वैल्यूज हैं which are allowed or not allowed?
not allowed.
Not allowed. Region of convergence is saying you have to be in a point whose distance from the origin is more than 1. Right? You should be able to read mathematics as phrases. Right? मैथ तो कोई भी थोड़ी देर में समझ आ जाता है ना. If you cannot read mathematics in English as phrases, as something with a physical interpretation, something is missing in your understanding. Right? That will carry on. मस्ता बढ़ता है उससे. So always, once you get the physical interpretation of something, lock it. अभी तक आपको you should know. When I say modulus of a complex number, I'm talking about how far is it from the origin. In fact, the modulus of a real number is also this. 4 का क्या मतलब होता है? 4 मतलब origin से 4 यूनिट दूर है. Yes? -4 का क्या मतलब होता है? origin से 4 यूनिट दूर है. दोनों का मॉडुलस क्या होता है? 4 होता है. Right? क्यों होता है? आप लोग इसलिए कि वो मॉडुलस we applied. No.
Distance.
It's the distance from the origin. Yes, so if you are on a line, that makes a interval. If you are on the plane, it makes circles. Yeah. So what's the region of convergence here? Outside the unit circle. So they are saying, okay, the z transform of a unit step will exist, and it will be this, as long as you don't choose a z inside or on the unit circle, you stay outside the unit circle. Okay, so you have now found another important z transform pair, which is that un has a z transform z over z minus 1. Okay, अच्छा. I'll just briefly mention the next few steps and then we will finish. So, do you remember convolution? Yes. After doing or defining or say looking at the physical interpretation of the convolution, we discussed how do we actually go about performing convolution, right? What did we discuss? There were 3 branches. क्या क्या थी? Okay, so graphical methods, some of those methods, right? What else?
Tape method.
Tape is graphical, that's fine. What else?
Mathematics.
There was through formulas, which also involve graphical methods and etc. You could use a solve it through properties, right? And thirdly, you could solve it through MATLAB, right? Similar holds for our friend here. So now we are moving away from basic definition, examples of ROC, all that, to more generic question. Okay, we have got the basics in hand. Now let's go and see how do we actually perform the Z transform. अब एक practitioner, एक simple person who uses a calculator or a computer to get Z transform, between that person and between you, the difference should be अभी से पहले जितने lecture Z transform पे हुए, right? Those interpretations, if you understand, then you really know the depth of it. जो आगे मैं बताने जा रहा हूँ MATLAB वगैरह से या कई चीज़ें, many people can do that, right? So let's see. How do we perform the Z transform? Computationally with the help of a computer. I will just write MATLAB for now. Doesn't mean it has to be MATLAB, okay? Can be Python or C++ or anything. What I mean is with the help of a calculator, computer, advanced machine, yeah? That's one. Second is by definition. Did we just find some by definition or not? Did we find the Z transform of delta? By definition. We just started from that. We found the Z transform of unit step by definition. MATLAB you will see in the lab, inshallah, this week also. Third is actually by far the most common on pen and paper, which is properties and pairs. यहाँ तक convolution का भी ऐसे ही था. There were properties of convolution. It's associative, it's distributive, it's commutative, it has an identity, delta, and those were what we call properties. And then there were pairs. The convolution of delta with delta is such, delta with un is such. आपकी book में था ना table. Exactly like that for transforms. और ये आपको remind करेगा पूरा का पूरा किसका? Derivatives and integrals. उनका भी तो यही तरीका है ना? Use a computer, go by definition, which becomes a headache often, right? Integral definition से करें थोड़ी देर में साथ हो जाती है. Often, if you're not going there, if you want to do pen and paper, where do you go? आप पता है integral of xn dn क्या है? xn plus 1 over n plus 1. आप दोबारा तो नहीं वापस जाते हर दफा. You know some pairs, you know some properties. Integral is linear, so integral of xn plus log x, let's say, dx, you know they have the property that they can be split, right? ये property से आप कर रहे हैं ना?
Yes.
Yeah. So this third one is what we do mostly on pen and paper. This we get started by, but usually it's both अहम functions, थोड़े से बड़े functions हो जाएं, it becomes mostly useless. Yeah, hard होता है. This is where a lot of your next work lies, and in the lab, this one. Okay, दोनों आने चाहिए आपको. ठीक है? This what we needed to cover. I've already mentioned it here, and as we have already seen a couple of properties, and so I'll write a couple of these properties and pairs. Firstly, pairs. आपकी book में एक पूरा table है. Just look at that. You do not have to memorize those, okay? I provide the tables. Properties के भी और उसके भी. लेकिन I do expect that you know some very basic ones like delta n का z, un का z, and that delta n is identity of convolution, those kind of very few. Otherwise, I provide the tables. So we're talking about pairs now. Pairs means time में अगर ऐसा है तो z में कैसा लगता है वो सिग्नल. We have already done this pair. What is it? Delta n 1. Yeah. Now there is also always here ROC. I'm going to skip that because बड़ा cumbersome है. Just look at the table in the book just to get an idea. I'm not too keen on saying that okay, find the exact ROC of this and that. What I want you to know is the interpretation of that and how we get to it. तो आज हमने जो किया है, अगर आप उसको थोड़ा revise, if you do that, it's enough. Okay, you get the concept. Delta n has a okay. The other one is un. What was that? Z over z minus 1. Okay. Then you have what we call this third one. What happens if in time you multiplied by an exponential? So what happens in frequency? Basically z over z minus gamma. Okay. So these I have shown a couple of pairs. In the book you will have many more. So cosine omega n है, उसका z transform क्या बनेगा? Right? Such very common functions. You have a table in the book. Then there are the properties. As I said, this thing we solve with the help of pairs and properties. So there is a table of pairs and there is a separate table of properties. So properties are very straightforward. Firstly, I'll mention a few and then I'll let you read the rest. Linearity. The Z transform happens to be linear. It is very useful. Okay, what does that mean? That means that a1 x1 n plus a2 x2 n has a Z transform which is a1 x1 z plus a2 x2 z. What does that say? That is saying you can separately take the Z transforms of these and put them in the exact same weighting like the original and you are done. Okay. So with each property there is a region of convergence change where I will not go into that. You can see it in the table. Shift, very important property. If all of this assumes that xn has Z transform x z. Okay. So what if xn has transform z? Then what happens when you shift xn by m units? A shift in time. How does it reflect in frequency? Okay, that's a very important property. And you know what it does? Basically, so originally xn had Z transform xz. If you shifted xn in time, there is a multiplication by z minus m. This is an important property. Then the third important property is convolution. You already know that actually. What is it? If you are doing a convolution in time, what happens? It becomes, and you will draw both ways because this holds two ways. It becomes product. This we have actually discussed a lot of times. Fourth one, what if you multiply in time with gamma n? This briefly I have already shown you, but we can. So xn had Z transform xz. What if you multiply xn by gamma n? You know what happens? ये क्या हुआ ये operation? Can anybody tell me? Divide? Yeah. Right. Right, yeah, you could have said logarithm, so it's still better. But जब हमने signals की basic function पढ़े थे, translation वगैरह, which one is this? Compression or expansion?
Expansion.
Think about it.
Compression.
Expansion.
Think about it.
Extension.
expansion कौन कौन कह रहे हैं? हाथ खड़े raise your hand. डर क्यों रहे? Right. And compression. अच्छा बाकी न्यूट्रल्स बैठे हुए हैं. न्यूट्रल्स चले यार रिकॉर्डिंग हो रही है. Okay. You are both right and both groups are wrong. Depends on gamma. If it's greater than 1, right, it is expansion. If it is less than 1, it is compression. Okay, so multiplication by an exponential in time leads to compression or expansion in the frequency or z domain. Okay, then there's 2 more and then we're done. I'm not proving any of these. Proofs of these are in your book. I have already shown you a couple of these or some of the pairs, and it's not really too hard to prove most of them. Fifth one is what happens if you multiply with n in time. You see the difference? Yeah, here you multiply with an exponential gamma. What happens if you had xn xz, but now you multiply it with n here? What happens in the frequency domain? Any wild thoughts? It's very amazing what happens actually. Our old friend calculus shows up. टाइम में आपने सिर्फ एक n से मल्टीप्लाई किया है और फ्रीक्वेंसी में it becomes derivative. Okay? And this thing actually you have used in solving differential equations without actually knowing it. I will come back to that later. आप ये use कर चुके हैं actually by some other name, D operator या फिर क्या कहा होगा. You have used this in circuit analysis too, or are using it, and in differential equations also. But I will come back to that. So that's 1, 6, just 2 more, 1 more to go after this and then we're done. Time reversal. ये याद है?
Yes, sir.
If xn is like this, xn minus n, what it does? Reverses in time, right? Most of you got that right in the midterm, mashallah. I was not expecting. मेरा आप फिर गलती करेंगे. और अगर यहाँ माइनस हो तो रिवर्सल इन दी एम्पलीट्यूड ऐसे वर्टिकल. यस, ये हॉरिजॉन्टल. What happens if you reverse in time? Well, z is replaced by z inverse. Okay. Lastly, what happens if you take the conjugate in time? Okay. Of course, if xn is real, nothing will happen, right, to it. लेकिन अगर xn is complex, then conjugate will change the sign of the imaginary part, right? So how does that reflect in frequency? It's actually a conjugate and a conjugate. It's z is replaced by z conjugate and the whole thing is replaced by x conjugate. Okay, so next lecture what I will do is I will start from here with some pair and properties. It's good to bring the book or the pages of the book where you have these 2 tables, because I'll give you several problems to solve where you will have to use the pairs and these properties, okay, to solve various things. For example, a quick one is this. Let's say I just ask you to give me the z transform of, let's say, okay, something is wrong. Where is that? Where is page 5 then? Can anybody help me find the z transform of delta and minus k? जैसे आप सोच रहे हैं we can help you find it, but we can't ensure it will be the right one. Yes, perfect. Z Z
minus kx.
नहीं बस आगे खराब हो जाएगा. That's it.
Delta की वजह से सिर्फ ये
Why is that?
क्योंकि
In here you use both the property and the pair.
Yeah.
The pair was delta n had a Z transform 1. The property says of what? Which one? कौन सी apply होगी?
second
Second, shifting. If this had a Z transform 1, its shifted version by m units will have a multiplier by Z raised to that unit, which is k here. So Z minus k, right? So already you can start playing around. बहुत powerful होता है. इससे आप you can solve a lot of different variations, yeah, which would be a headache to do by definition every time. Okay, so yeah, I think we are mostly done. कोई questions वगैरह?
सर एक क्वेश्चन के कोर्स के अंदर पहले हफ्ते जब हमने क्लासेस वगैरह ली थी ना, तो टाइम हमें 8 बजे बताया गया था. हम लोग
अच्छा.
सुबह 8 बजे पहुंच
उठा
जाते
जाए एक
थे.
सेकंड पे. इससे related नहीं है कोई सवाल? Any question related to the topics, then I'll close it, and the world doesn't have to hear about our